Hi everyone, welcome to our video on the derivative of the natural log function. So in this table we've got the derivative rule. The derivative of the natural log is 1 over x. And also if they put that in absolute values, the x here, then it's still the same 1 over x. Okay, so we've got our rule for whether or not it's using absolute values is the same. And then this is the chain rule portion of it. So the first one is the most basic way, but usually we have to use the chain rule. The chain rule tells us that whatever is inside the log, the u of x there, we just put that in the denominator. And then in the numerator, we times the in the numerator, we put the derivative of this expression. So this is the other way to look at it is u, and then up top is derivative of u. And that's it. Okay, so it's a pretty nice scenario, and then notice the absolute values also does not change anything. All right, so let's see how this problem, or how we can work on these problems. So in number 1, it says y equals the natural log of 20x, and we need to find the derivative. So the derivative dy dx is equal to, so I see the 20x is like the u, and I just think I instantly just put it down in the denominator, and then I think, all right, times by what I just wrote, derivative in the numerator. So the derivative of 20x is 20. And then we can see, oh, 20 and 20 divide. So we got dy dx is really just 1 over x. Look at that. Oh, that's unusual, huh? So the 20 just cancels and we get kind of the same thing that we got over here. Okay, so that's neat. So that happens a lot with these log problems. So that will actually happen whenever it's any just constant times your x. Okay, but I would still say just go through the process, and it takes one step and you got it. Okay, so let's see number 2. So on number 2, we're finding the derivative f prime of x. Well, this 3 is a constant that multiplies the front, so it's still just going to be there. So let's set up the 3 just hanging out. And then now the derivative of this natural log function is to put this expression, the 4x squared minus e to the x, just in the denominator. And then I think, all right, well now just multiply the numerator by the derivative of this. So the derivative of 4x squared is 8x. And then the derivative of, we have minus, the derivative of e to the x is e to the x. And there we go. And that's it. All done. One step. Okay, so a lot of these are one step. So the chain rule with these, so the functions that look kind of worse maybe, the natural logs and the e's and the other bases, actually kind of work easier than some of the ones we've seen in the past. Okay, so that's all there is to it. All right, and then moving on, let's see how number 3 works. So on number 3, just like always, when you see that square root, it's probably worth it to rewrite so that it's written like this. Well, let's add one rule here that's very useful for us. Whenever you have the natural log of some expression, I'm just going to use m, raised to a power, we can rewrite this as p times the natural log of that expression there like that. Or let's put it like this, which is parentheses. So this power moves to the front. So this is just a rule for logs. This is not a calculus rule. This is just a rule for logs. So that makes this problem a lot easier. And it only works when the whole expression is raised to the power. So notice on this one that was above, I didn't have anything that was raising all of this to a power. So I don't want to just take that 2 and I didn't want to take that 2 and move it to the front. That's not the same rule. Okay, so let me erase that. So that's not the same thing. It's only if the whole thing like this whole argument is what they're called, is raised to a power. Okay, so let me clean that up a little bit. That was minus 7 in parentheses. Okay, so this is raised to a power, so that means this 1/2 multiplies that 8. So we would have, so this, and this is still just g of t, so no calculus yet. It is just that would, and we will simplify that, is the natural log of 3t minus 7 left over, just like that. Okay, and then now let's simplify. I'm going to put it up here. So it's g of t equals the 8 times the 1/2 is just 4. And then we have the natural log of 3t minus 7. Okay, so a little bit of simplifying can make this a little easier. Now we can do this derivative with no problem. So the derivative g prime of t is 4. This 4 is just hanging out. And then I'm going to set up a parenthesis and a set of parentheses like this and say, all right, the derivative of your natural log portion is to take the argument, the 3t minus 7, and put it down in the denominator. And then to take this same answer and put the derivative of it in the numerator. So the derivative of 3t is 3. Derivative of negative 7 would be 0. Okay, and the only difference between the previous problem and this problem, I mean, you could box this is okay, but the 4 would times the 3, so we could simplify it a little bit further. So g prime of t, 4 times 3 is 12 over 3t minus 7. There it is, that's it. Okay, you could have done this problem the same way that we did number 2. So you could have set this up. I'm going to put it right here, g prime of t. So I'm looking at this before I move it over. You could say, hey, couldn't I just put that 8 there? And then let's put that 3t minus 7 to the half power down below in the denominator. And then the derivative of this in the numerator. Well, yes, it works, but then you have the chain rule. Okay, so it's not a big deal, but so the derivative of this denominator would be 1/2 3t minus 7 to the negative 1/2 times the derivative of the inside, which was 3. Okay, so I got a little messy on me, sorry. But you could have done it like this, and it's messier. Eventually, it would simplify to give you the same exact thing, though. It would be this. But this is a lot more simplified and easier to work with. Okay, so use this rule when you can. I think it's a nice one. And on number 4, we could use it again immediately. So on number 4, notice, let's read it. S equals 4t times, that is times because it's blank, times the natural log of 9t minus 2 to the t all to the third. Okay, so this is, let me rewrite it so I can put those parentheses in. 4t times the natural log of 9t minus 2 to the t, that one's all to the third like that. Okay, so this means we need to use the product rule. All right, so that means this is like our u, and this here is our v. But before we do that, let's do one other thing to it. Okay, so that would be in parentheses. Let's use this same rule. Let's use this rule right here on this 3. So this 3, we would want to move to the front like that. So then now let's write it as S equals 4t times 3 natural log of 9t minus 2 to the t in the absolute values, and then parenthesis at the end. Okay, so that might make things a little nicer for us. And then now let's do our derivative. So we've got, and this is still the u, it's just the v was modified to be easier to work with. Okay, so our s, I'm going to use ds dt for our derivative notation. Okay, so it is the product rule. I usually like to set it up as u prime v plus uv prime, so I just make sure to alternate. And then let's put this horizontal since I might run out of room. And then our u stuff, I'm going to keep in blue. So this I can look at and we could just do the derivative of u is 4. And then v we could just rewrite. So 3 natural log of the absolute value of 9t minus 2 to the t. There we go. And then plus, okay, so now that one, let me get my colors marked. And then plus just u, which is just 4t. And then we'll times it by the derivative of v. Okay, so the derivative of v, this 3 would just be hanging out. And then times, all right, so I see it's a natural log. So that means put this expression, the 9t minus 2 to the t, in the denominator. Like that. And then in the numerator, we'll do its derivative. So the derivative of 9t is 9. And then minus the derivative of 2 to the t. Well, the derivative of 2 to the t is itself times the natural log of 2. So remember, when it's a base raised to a variable power, and I just need to put that in natural log of 2 like that. Remember, when it's a base raised to a variable power, the derivative is itself times the natural log of the base, also times the derivative of the power. The derivative of t would have been 1 though, so I'm using the more basic rule. Okay, so that's what this turns into. And then at the end of it all, it looks like maybe simplify what you can. So our ds dt is, well, this 4 and that 3 multiply to give us 12. And then we could write the natural log of 9t minus 2 to the t in absolute values. And then we have plus, let's see, anything here? Well, this 4 and that 3 would also multiply to give us 12. So it's plus 12 and then t. And then times this thing in parentheses, the 9 minus 2 to the t natural log of 2 over 9t minus 2 to the t. Okay, and that's it. That's good. And that's it. We'll be done. Okay, so that's how we can break down some of these rules with the natural log. So notice our rules are pretty nice in words. They work out pretty fast. They can still be tricky if you have to use like the product rule or the quotient rule. Still take your time with those. All right, but that's it for now. If you do have questions, please let me know. Otherwise, thank you for watching.